Alright guys, this is Unit Mathematical Models. Our objective for today is to write, solve, and interpret linear models. By the end of this video, you should be able to complete this problem. A farmhouse shelters 10 animals. Some are pigs and some are ducks. Altogether, there are 36 legs. How many of each animal are there? Keep in mind that pigs have 4 legs and ducks have 2. Linear models. In your book, it gives you 2 types of linear models. Just always think of it as this form. So the form that we're going to be going over is f of x equals m times x plus c. So f of x, this represents the function and is also the output where we would normally see y. M is the gradient. You'll also hear me frequently call it the slope. I'll try to use gradient as much as possible, but it's just the terminology that we use in the States. X is the input. So remember, for every function, you have an input and you have an output. C is the constant, and in the linear model, when you're graphing it, the C is also the y-intercept. And for every y-intercept, the 0 is the x value, and then the y value is where it crosses on the y-axis. Okay, and I'll show you what that means in a second. So, before we move on to the linear models, we need to understand the gradient or the slope. So the formula for finding the slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You can also say y2 minus y1 over x2 minus x1. Those are both ways of saying the same thing. I wanted you to hear saying sub because I say that a lot, and it's hard for me to get out of certain habits. Okay, so the way that you input these values is that you'll have some point x, y, and you'll have another point x, y. The first one you can put as 1, x1, y1. The second point will be your x2, y2. It doesn't matter which point is which, but in one point you have to use the sub 1, sub 1. And the other point you have to use sub 2, sub 2. You can't do x sub 1, y sub 2. You can't do that, okay? I'll show you what I mean. So, for this first example, we have a graph, and it's right here. All you have to do is identify 2 points. So there's one right here and one right here. So I'm going to label those points as here, this is 0, 0. And then up here, the x value is 4. The y value is 6. Okay, so I'm going to rewrite those below. 0, 0, and 4, 6. Now, I want to label each of them as x1, y1, x2, y2. So, above, I'm just going to label them. So this is going to be my x. I don't know if you can see that. Let me do a different color. Still don't think you can see that. Okay, let's do it down below. So this is going to be my x1, y1, and then the next point is going to be my x2, y2. Okay, you could do this one x2, y2, or this one, and this one x1, y1. Okay, both of these are acceptable, but you are not allowed to do x1, y2. This is bad. Do not do that. Whichever point you label as 1, you have to do both the x and the y as that. Okay, we're going to go with the first one, so I'm just going to delete these other two below. Now, all I have to do, now that I have them labeled, all I have to do is put them into this formula. Okay, so m equals y2, which is 6, minus y1, which is 0, all over x2, which is 4, minus x1, which is 0. 6 minus 0 is 6, and 4 minus 0 is 4. You always want to simplify, so if I simplify this, both of them are divisible by 2, so I get 3 halves. That is the m. Okay, let's do another example. Here, they don't have the points pointed out for me, but I can clearly see that this is a point, and we'll take this as a point as well. Okay, so let me label that. So this point is 2, 0. This point is 1, 3. And I'm just going to bring those down. So I have 2, 0 and 1, 3. So in the previous example, I did x1, y1, x2, y2. So I'm going to switch it and do x2, y2, x1, y1. Either way, it doesn't change your answer. You'll always get the same answer as long as you're consistent. So m is going to be y2 minus y1. So that's 0 minus 3. Sorry about the car. And then your x2, which is 2, minus x1, which is 1. And then I evaluate. So 0 minus 3 is negative 3. 2 minus 1 is 1. Negative 3 divided by 1 is just negative 3. That is the gradient. Okay, this next one, it says the points negative 2, 4, and 3, negative 6 are on the graph of C of t. What is the gradient of C of t? I don't have to have the graph in front of me to find out the slope. I can just put these 2 points into the slope formula, or the gradient formula, okay? So I already have these points, so I'm just going to copy them and put them down here so that we can label them, because I want to make sure that I'm organized and that I don't make any mistakes. Okay, so let's label this one as x1, y1, x2, y2. If you want to test to see if you get a different answer, you could always do the opposite and do x2, y2, x1, y1, and see if you get the same answer that I do. Okay, so m equals y2, which is 4, minus y1, which is negative 6. Notice that I'm putting it in parentheses. All over x2, which is negative 2, minus x1, which is 3. So 4 minus negative 6 is 10. Negative 2 minus 3 is negative 5. 10 divided by negative 5 is negative 2. That is the gradient of C of t. Make sure that if you have any questions, you're writing them on the side, so that way when I come around to check your notes, you can ask me, okay? Or you can come in and see me tomorrow. I sent you guys an email about when you can come see me during school time. Anyway, let's move on. So, conversion graphs, when you're going from one unit of measure to another, you'll use a conversion graph. Basically, what that means is that your y-intercept, your constant in the linear model, f of x equals mx plus c. The c will be 0, so you won't see it there. So basically, you'll have a function that looks like this because c will equal 0. The reason why is because for most units of measure, like if I move 0 miles, I also move 0 kilometers, right? Both of those are at 0. The only thing that doesn't work with when you're doing conversions is, or not the only thing, but one of the only things is temperature. So when I'm at 0 degrees Fahrenheit, when I'm at 0 degrees Celsius, I'm actually at 32 degrees Fahrenheit. So it doesn't really work with temperature, but for most units of measure, it works so that your C is 0. Okay, for this example, we have 1 mile is equivalent to 1.6 kilometers. We want to find the gradient. Now, you can choose either mile or kilometer to be your x and the other one will be your y. However, you want to think about putting whichever one is 1 as the x, because in your gradient formula you have m equals y2 minus y1 over x2 minus x1, right? So if my unit, which is 1, is the denominator, the x value, then that means I'm just dividing the y value by 1. Okay, so let me show you what I mean. Let's make our mile the x value and the kilometer our y value. So this is going to be the x value, the input. This is going to be the y value. Okay, so if I wanted to, and also you have another point, it's implied that when you have 0 miles, you have 0 kilometers. Okay, so now you have 2 points, 0, 0, and 1, 1.6, right? So for when I'm at 1 mile, I'm at 1.6 kilometers. All right, so now that I have 2 points, I can put them into my gradient formula. So, and like I said, it doesn't matter which one you label as x1, y1, x2, y2. You're still going to get the same thing. Okay, so y2 is 1.6 minus 0, that's y1. And then x2 is 1 minus x1, which is 0. And so you get 1.6 divided by 1. And 1.6 divided by 1 is just 1.6. That is the gradient. Okay? Now, because your y-intercept is 0, 0, that means the c equals 0. Okay? So all you have to do to find the linear model is to input the gradient into f of x. So your linear model is f of x equals 1.6x. This is a conversion model. Okay? If you didn't understand what I said, pause, go back about a minute, 2 minutes, and rewatch it. Okay? I'm going to recap what we just did. So, whenever you're doing conversion graphs, if I'm at 0 miles, I'm at 0 kilometers. That's why we got this point right here, the 0, 0. Okay? We got the 1 and 1.6 point because it tells us in the example 1 mile is to 1.6 kilometers. Okay? So we have 2 points. We put them into the gradient formula. and we got the gradient of 1.6. The reason why we chose 1 mile as our x value and not our y value is because you want to have a 1 down here in your denominator, because it makes it easier when you find your gradient. You could have done it the other way around, where you divide 1 by 1.6, but it typically gets messy. It's easier just to have a 1 in the denominator. Okay? So, now we're going to go on and we found the gradient. We found the linear model. It's right here. F of x equals 1.6 times x. Our input is x, our output is f of x. Okay? Now we're going to draw the conversion graph. All right. Now, to draw a conversion graph, all you have to do is know 2 points, right? So we have 1 and 1.6 kilometers, and we also have the y-intercept, which we said was 0, 0, right? If I wanted to do whole numbers instead, I could say input 10 into x, because I know that when I multiply 1.6 times 10, I get at a full number, which it could be 16. Okay, so another point, if I input 10 into my function, I get out 16. So now I have two numbers, 0, 0 and 10, 16. So remember, you're always going to use a straight edge, and you're just going to make yours a lot better than mine. My technology does not do very well with making graphs, so be patient with me, please. So 2, 4, 6, 8, 10, and we'll do the same thing on the y-axis. Actually, let's go by 4s, so that way we can fit it all in here. So 4, 8, 12, 16. And label your x-axis. And then you're just going to plot your points, right? So I have 0, 0, it's about right here. And then 10, 16, which if I go up and then I come over, is right here. Okay? And then I just make a line through those 2 points. And that is my conversion graph. Alright, so moving on. In a chemistry experiment, a liquid is heated and the temperature at different levels is recorded. So we have a table of information. We want to draw a graph for this data. And this is going to be really simple. Again, you want to make sure that you're using your straight edge to make your graphs. And then the x-axis. Time is going from 2 to 9, so I'm going to do the same thing that I did before, and I'm just going to go by 2s. 2, 4, 6, 8, and 10. And then along the y-axis, I have to get up to about 65. So let's do by 10s. 10, 20, 30, 40, 50, 60, and you should be using graph paper, so yours are equal widths apart. Let's fix this 30. Okay, now I'm just going to go through and plot these points. So at 2, I'm at 30, so come up to 2 and at 30. At 4, I'm at 40. At 6, I'm at 50. And then at 9, I'm at 65. 9. Sorry for my sloppiness. Okay, I'll just erase those little marks. Okay, and then I just make a line through those. Again, mine's not going to be exactly right because I'm not using a straight edge, which is shame on me. Okay, so this is your graph of the data. Yours, I'm going to assume, looks much, much better than mine. There's a second part to this. You don't have to rewrite the example. So that was A. Now B says to find a model T of X, the temperature with respect to time. So that's what the T of X means, right? So temperature with respect to time. Time is going to be our X value, and temperature is going to be our Y value for these data. And we already did that here, right? We already knew that the time was going to be our X value. We already knew that the temperature was going to be our Y value. Okay, so all I have to do is find my gradient, and then I have to find my C, right? Because linear functions are of the form f of x equals gradient times our input x plus some constant c. Remember that c is our y-intercept, which means that the x value is 0. Okay? Alright, so we're going to pick any 2 points. Let's do 2 and 30. And let's do 6 and 50. You could have chosen any of these points, any 2 of them. You're going to get the same gradient that I get. Okay? If you don't believe me, try it out. See what happens. Go crazy. So I'm going to do x1, y1, x2, y2. Okay? And then I know that my formula is y2, which is 50, minus y1, which is 30, divided by x2, which is 6, minus x1, which is 2. So 50 minus 30 is 20. 6 minus 2 is 4. This gives us a gradient of 5. So far, I know that this m value is going to be 5. Now, I need to figure out this one. Okay? So, let's look at this. I have f of x equals 5x plus c. Now, I have 1 unknown, 2 unknowns, 3 unknowns, right? And when I say unknowns, I mean there's a variable here, there's a variable here, and a variable here. Well, the thing is that I can take any one of these points and put them into the function because I know that they are part of this function, right? So I know if I put in 6 into x, I'm going to get out 50. That leaves me with 1 unknown, c. So let's do that. I think 6 should be fine. Let's try 6. So my input is going to be 6, so I put that where the x is. Drop down my 5. You're multiplying those two things, so make sure that you have your parentheses so that way you know what you're doing, okay? My output is 50, right? Yep, 50. And then the one unknown is c. So now I'm going to simplify. So I have 50 equals 30 plus some value c. I don't know what c is, but I'm going to find out, right? So I want to get c by itself. That means I need to get rid of this 30. Now, I don't know if you guys use the same format that I'm doing, but the whole purpose of me writing down the next line is so that way I keep track of what I'm doing, and if I don't get the right answer, I can go back and look at my process and fix what I did wrong. Okay? So if I want to move 30 to the other side, some of you guys just go ahead and move it over, but I'm going to show you that I'm subtracting 30 from both sides, and this 30 and this 30 go away because 30 minus 30 is 0. So I get 20, because 50 minus 30 is 20, equals C. Okay? So now I know what this C is. It's no longer a question. I figured it out. It's 20. Okay? So I'm going to erase this gradient part. Okay. And now I've answered this question. I found the model T of x. T of x, which is the same thing as f of x, right? It's just that it's calling f of x something different. So my T of x is going to be 5x plus 20. Okay? Remember that we found the gradient by taking two of these points and putting it into the gradient formula. And then we found C by taking one of these points, putting it into the function, and solving for the one unknown, which was C. Okay? So now we have a model of the problem. Okay? Now, we want to use this model T of x equals 5x plus 20. We want to use this model to predict the temperature after 8 minutes. So my input is going to be time, which is going to be 8. So to answer I just input 8 into my x. So I get 40 plus 20, which equals 60. So the temperature after 8 minutes is 60 degrees Celsius. The temperature taken for the time taken for the liquid to reach 57 degrees. So we are given the output and we need to find the input. So where I have T of x, I am now going to put 57, and I'm going to find the input x. So 57 equals 5x plus 20, right? And so just like before, you guys normally just move it over without showing why you move it over. I'm going to do that just so that way I can keep track of what I do, and in case I mess up, I can go back and recheck. So 20 is positive, so I'm going to subtract 20 on both sides. I get 37 equals 5x. I divide both sides by 5. I get x equals 37 divided by 5. I'm fine with this answer, but the book isn't, and they give it in decimal form, and I guess that's what we should do too. So 7.4. That is not our answer. You have to put it in terms of the question. So the time taken for the liquid to reach 57 degrees is 7.4 minutes. Okay, now this last problem. This last problem is you're going to be using your calculator, and you need to have your book so that way you can finish this problem. Okay, because I'm not going to go through how to do your calculator over this video. You can go to the back of your book and look it up. Okay, so a carpenter makes wooden tables and chairs. He takes 10 hours to make one table and 4 hours to make one chair. The wood costs $120 for a table and $40 for a chair. We want to make two models, one for the time to make the table and chair, and then two for the cost to make the table and chair. Okay, so let's look at the first one. We need to designate table and chair as either the X or the Y. Since table is first, let's call it X. So my table is going to be my X value. My chair is going to be my Y value. So we're just making a model, right? So time is going to be, so it takes 10 hours to make X number of tables, or 10 hours to make X table. So if you made 2 tables, you would multiply that by 10, right? And then plus 4 to make Y number of, or so you would multiply 4 by Y depending on how many chairs you made. Okay, so that's the time. And then 2 wants us to find the cost, or make a model for the cost. So $120 per table, and then it's $40 per chair. So these are the 2 models, right? Time and cost. So that was simple enough, right? Okay, so the next one says if the carpenter works 70 hours, so that's time, and spends $760, that's cost, how many tables and chairs were made? So here, this model, I have 3 unknowns. This model, number 2, I have 3 unknowns, right? However many unknowns you have, that's how many equations you have to have. Okay, so there's 3, but we only have 2 things. So we couldn't do anything with these unless we had time and we had cost. Well, it's giving us the time and it's giving us the cost. So now we have 2 unknowns with 2 equations, and we can figure out the point, or we can figure out what X and Y are given the time and the cost. So when you go to page 470, it gives you two equations already. Instead of those equations, you're going to put 70 equals 10x plus 4y, and then 140, or wait, sorry, is that 740? 760. I don't know where I got 140. Okay, 760 equals, and then I think it's 120x plus 40y. Yeah. Okay, so you're going to put in these 2 equations. Okay, so like I said in the book, it gives you 2 equations to use in that example. Instead of those 2 equations, you're going to put in the 70 equals 10x plus 4y and 760 equals 120x plus 4y. So go to page 470, make sure you have your calculator, the Inspire, and input these 2 equations instead of the ones that it gives you. Okay, your answer should be 3 tables and 7 chairs. Okay, giving you the answer to check yourself. Okay, also try to do the first problem that I gave you in the video. And your assignment. Go ahead and get started on this, please. We don't have a lot of time. I'm trying to make up for lost time. So get started on your assignment. Come ask me questions. We're also going to use the time in class to ask questions. You're probably not going to like this, but there will be another video up, and I'm going to email it to you when it's up, okay? So page 148, 1 through 3, page 150, 1 through 4, and page 152, 1 through 5. If you have any questions, please, please, please come see me, okay? Night, guys.